get your classwork done that you are going to do on Monday, March 24th. So if you go to this, it's like what we were doing in class here. You're going to do most of these in your head, if not all of them. So this will be divide by square root of 2, and you get cosecant x is 2 over square root of 2, and then you flip it over to get the sine of x. So I'll start to show you their work. So you divide by square root of 2, and then you flip them over, and the sine of square root of 2 over 2 reminds us of pi over 4, but we have to give all the answers one time around. So that reminds me of pi over 4, and then I'm going to put a comma, because where else is sine positive square root of 2 over 2 would be in the second quadrant at 3 pi over 4. So it's a little bit easier than what you were even doing for homework over the weekend. So you just work these out, add square root of 2 and divide and find all your answers. This section can get really tricky, and I want to show you the easiest way to do this. So first of all, they want you to visually show where sine could be 0.98. Sine is positive in this quadrant, first and second quadrants. So you want to pick what's called the horizontal line. You want to pull it down to you're at 0.98, which is almost 1. So hopefully I'll leave it in kind of the right place. It doesn't have to be perfect, thank goodness. Hope that's right. We'll find out. And now I want to figure out what this angle is and what this angle is. Since I don't know the sign that gives me 0.98, I would have to use inverse trig functions. But inverse trig functions only will give me one answer, whereas I can clearly see there's two answers. So what I would say to do is go to your graphing calculator. I have sine. I'm going to put in 0.98. Get rid of that 1. And I need to put an 8. I think it was 0.98. Then go to second, calc, intersect. And you'll barely see 2 times where it equals 0.98. There's 1 here and 1 here. If you change your window, you see it a little bit better. I think you'll barely see it graze through. Oh, you can't still see it, but it barely hits that, like there's 1 here, then it goes up and comes back down. I'm going to go to second, calc, intersect. I'm going to move over closer to this one and go enter, 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 and I'll put in 1.8. They want 1 decimal, a tenth. So one of my answers is 1.8. Then I'm going to go find that first answer, second, calc, 5. I'm going to go over here, closer, and go enter, enter, enter. And I get 1.4. Okay, submit. Alright, so then it takes you through that. They use inverse trig functions, but it's a lot harder. You have to do more work to get that second angle. So let's do a new problem. So let's find a different one. Let's do tangent. All right, tangent is positive here and here, first and third. So I need to pick the diagonal line. And with tangent, you want to keep going till you see the number switch to 1.8. You don't get to see it on sine and cosine. You just have to estimate. But I can actually watch this number until I hit 1.8. All right, so I want to figure out this angle and this angle. So I'm going to go to my graphing calculator. It's easier than what Delta Math tells you to do. Tangent x, and I can literally see it hit 1.8. So I'm going to go to second, calc, intersect. And let's see how many we get for 1.8. 2 of them. All right, so I'll go find this one. I don't have to get real close. And I get 4.2. And then let's go find this one. Second, calc, 5. I'm going to move over here. And if you're tired of going that way, you can bump up and go on the line before you hit enter. Get over there kind of close to it. Enter, enter, enter. And I get 1.1. Okay, let's find a cosine. Oh, there's a good one. Cosine's negative 0.35. Cosine's negative over here, second and third. So I'm going to pick a vertical line. Really makes you think about it. I'm going to try to get it at about negative 0.35. So about in the middle there. Negative 0.2, 0.35. And then I'm going to go to my calculator and put in cosine. Notice my window. That might help you. I mean, it wouldn't hurt to go from negative 3 to 3 or negative 2 to 2. And I'm at negative 0.35. So you'll actually see it hit twice. And this is way better than inverse trig functions because you see both angles, or however many there are. Enter, enter, enter. And so I get 1.9. It's 1.9 radians. I'm in radians. And second calc 5. I'm going to go up to the line and move across that way. Enter, enter, enter. And I get 4.4. All right, and then the other section is what we did today. If I add 6, I'll get 10 is 1. Okay, and I'm supposed to give, let me see, what was the question? Find the general solution. So that means all the values in the whole wide world where tangent is 1. Tangent is 1 at pi over 4. And then you can go in and say plus 2 pi k. And you're going to pick where it's an integer, whichever one that is. Then tangent is also positive in the third quadrant at 5 pi over 4. And then you can say plus 2 pi k to go around again. There is another way to do this. You could just, since the period of tangent's pi, you could just use this one and get rid of that too. But if you want to just keep adding 2 pi k, that'll generally work. Let's see what we got here. All right, so new problem. All right, what I would do is subtract 1 and divide by 2. So I'm looking at where sine is negative 1/2. And so I got to think about all the times sine is negative 1/2 and then add 2 pi k to it. So sine is negative 1/2 at, in the third quadrant, 7 pi over 6. Go in and put in plus, to keep it going, 2 pi k. And then any integer. And then 11 pi over 6 plus 2 pi k, where k is any integer. Okay, and make sure you do all of these for a homework check by the next class time.